Algebra 2, graph quadratic functions in standard and intercept forms. And this is Teacher Talk, Concept 7. So what I want you to do in this Teacher Talk is to test your knowledge from the notes of the 3 different forms of a quadratic equation. So we have vertex form, standard form, and intercept form. So look at problem number 1, and for these 3 problems, you want to graph the quadratic function in whatever form you're given. It says in standard form, but it may not be in standard form. We're going to label all the things that we're asked to label. So look at that equation, look back at your notes, pause the video, and then determine what type of quadratic equation this is. All right, if you matched it with intercept form, then you are correct. So with intercept form, the first thing we want to pick out are the x-intercepts. So remember that it's in terms of subtraction. So you say, what number is being subtracted from the x's? Well, a positive 3 and a negative 1. So that means you have x-intercepts at the points 3, 0 and negative 1, 0. Now for the vertex, we'll start with the x value of the vertex, which is also the axis of symmetry. So I'm going to show this work down by the AOS, which is axis of symmetry. So you find the middle of P and Q. So you're going to add 3 and negative 1 and divide by 2, which will give you positive 1. So that's the x value of the vertex. To find the y value of the vertex, you're going to plug in 1 into your equation. And when you do that, you get negative 2 times 2, or negative 4. So the vertex of this quadratic equation is 1, negative 4. Now, before identifying the domain and range, let's go ahead and put that vertex right in the middle of our table. And then put 2 values down in, with intercept form, then just put your 2 x-intercepts. And we can graph this quadratic with these 3 points. So draw your xy axis, label it, and label a scale. Now go ahead and plot these 3 points at 3, 0, 1, negative 4, and negative 1, 0. And then you'll draw a parabola which opens up and has an axis of symmetry at the line x equals 1. Dash that axis of symmetry in right down the middle. Now your domain of a quadratic equation, a general equation, is always all real numbers. You can plug in any number for x and get a real number out. Our range is limited though, so the curve only uses the y values that start at negative 4 and are greater than negative 4. And then does this graph have a maximum or a minimum? Well, you can see that it opens up, so it has a lowest point. The vertex, it has a minimum. All right, do the same for number 2. So pause the video, look back in your notes if you need to, or if not, just determine what form of a quadratic it is and write that. All right, if you identified this as vertex form, you are correct. So for vertex form, let's start by picking out the vertex, the h and the k value. So remember the h is in terms of subtraction. So what's being subtracted from the x? A positive 1. And then the k is just the sign that you see. So our vertex is again at the point 1, negative 4. The axis of symmetry is always the x value of the vertex, but we write it in equation form because it's a vertical line. Now put your vertex right in the middle of your table and then place 2 values in the negative direction for x and 2 values in the positive direction. Plug in negative 1 and 0 and you'll get 8, negative 1. And then your y values on the other side will be symmetrical values. You can plug it in to check to make sure. All right, let's plot these points. So draw your xy axis, label it x and y, and label a scale. So looking at the equation, this is going to be a narrow U-shaped curve opening upward. And then sketching your axis of symmetry, and that's the vertical line where x equals 1. Again, the domain's all real numbers, but our range is limited. It's all the y values, just like the last one, that are greater than or equal to negative 4. It has a lowest point, and so it has a minimum. All right, I bet you can just guess what form this one's going to be in. You got it. It is standard form. ax squared plus bx plus c. So here we'll start by picking out our a, b, and c values. So a is negative 2, B is positive 4, and C is 3. Now we have to work a little harder to find the vertex. So the x value of the vertex, I'm going to place it down in the axis of symmetry because it's also the equation for that. So x will equal the opposite of b divided by 2 times a. So that'll be negative 4 divided by negative 4, which is positive 1. So plug positive 1 into your equation for x. So remember, we'll do the exponent first. So negative 2 times 1 plus 4 plus 3 will equal 5. So we have the point 1, 5. Now place that in your table and then put x values in the negative and the positive direction. Plug each one in your equation and you should get symmetrical values around the point 1, 5. Label your xy axis and your scale. And then plot your points. So this graph will also be narrower because of our a value, and it's going to open downward because our a is negative. So we have a narrow U-shaped curve. So sketch that dashed line right down the middle, our axis of symmetry. And now let's identify the domain. You got it, all real numbers. Now the range, since it's opening downward, it will be all the y values that are less than or equal to the y value of the vertex. And since that's the highest point, that is the maximum. There's quite a bit of memorization in this concept. You just want to memorize those 3 forms of a quadratic equation. They are also on the note sheet or the reference sheet that you can use during quizzes and tests, but it's good to memorize, and then also memorize the process for each form on how to pick out those important points. So the values, and then to find the vertex, and then how to plug in numbers for x to find y and create the graph.